first question, as I mentioned earlier, so say this is similar to question number 1 in the past semester exam papers, where the first question will deal with chapter 1. Okay, chapter 1, that is introduction to statistics, so the fundamental of the statistics. And for this part, the first part will be a true false. When in this case, say the first question asks you, quota sampling requires a sampling frame. So is this true or false? Okay, what's your answer? Do quota sampling require sampling frame? Okay, what's your answer? Do they require sampling frame or not? So in these questions, what is a sampling frame? Okay, let me just revise, give some revision on this one. So what is actually a sampling frame? Okay, a sampling frame is simply a list of all the elements in the population under study. Okay, so normally we require the sampling frame whenever we deal with probability sampling. So when you have a probability sampling, most of the time you require a sampling frame. Okay, however, if you are doing non-probability sampling, normally you don't require any sampling frame. Okay, the only things that require sampling frame will be the one whenever you are using the random sampling. So the random sampling covers the 5 techniques that we discussed in the class. So that is the simple random sampling, SRS, systematic sampling, stratified sampling, cluster sampling, and multi-stage. Whereas some other sampling technique discussed in the class will be just a non-probability sampling or non-random that do not require any sampling frame. So this include quota sampling. So in this situation, when we deal with sampling frame, so quota sampling is a non-probability sample. So that means you don't require any sampling frame. So that one, this. So this will be false. Okay. The second one is 1/2 of all the data values will fall above the mode, and 1/2 of all the data values will fall below the mode. So this is also a false statement. Okay. So the key points here, the keywords here is 1/2. Okay, whenever you have 1/2, normally this refer to not the mode, but is actually the median. Okay, so 1/2 below, 1/2 above the median value, not the mode value. So this means that this statement is a false statement. Okay. The third one, when the mean is computed for individual data, all values in the data are used. Okay, so when mean is computed for individual data, all values in the data are used. So in this case, what it means here, when you calculated the mean for individual data, this means that you are using the ungrouped data set. So when you calculate the mean using the ungrouped data set, you must include all the values. Okay, so that means this one is true. Okay, so that is the answer for the first part. For the second part, okay, ask you to determine monthly rental to determine the monthly rental prices of apartment units in Kota Damansara. The sample can be selected in several ways, either probability or non-probability sampling. Identify the sampling technique used to produce each sample as below. So let's see one by one. Okay, what are the sampling technique used in each of the statement? So the first one state that number all the units in the area and use random number table to select the apartment to include in the sample. So in this case, it says that you are doing some kind of a lottery methods. Okay, some kind of a lottery method where you list all the elements in the population, and then you give number to each of the element, and you pick one by one. And the keywords here is using the random number table, and you number all the units. So this is the keyword. So that means you number all the units, and then you choose using random number table. So this is the definition for simple random sampling. Okay, SRS. Okay, the second one, classify the apartment units according to the number of bedrooms, and then take a random sample from each of the classes. Okay, so in this case, remember yesterday I mentioned that if you want to determine the sampling techniques, so first of all, you need to identify whether is there exists any grouping or not on the populations. If there exists grouping, that means your answer gonna be either cluster, stratified, or multi-stage. And multi-stage only applies whenever you have a second level of grouping. In this situation, there's no second level of grouping. There exists a grouping because it says here you classify. Okay, the word classify come from the classify means you are doing some classification, or some classification means that you are grouping into certain groups based on certain criteria, and the criteria that they are using here is by using the number of bedrooms. So that means in this case there exists grouping. Okay, so when there exists grouping, so your answer gonna be either cluster or stratified or multi-stage. But in this situation, multi-stage is not possible because there's no second level of grouping. There's only one level of grouping, that is by number of bedrooms. Okay, so let's say which one is the correct one. Is it stratified or cluster sampling? Okay, look at another keywords. It says here sample from each of the classes. So they want sample from each of the classes, meaning that each of the classes must have a representative on the total sample. So this is a definition for stratified sampling. Okay, so you have stratified. And then the last one for this part is look in the newspaper and choose any apartment listed in the advertisement of rental properties in Kota Damansara. Okay, it says here look in the newspaper and choose any apartment listed in the advertisement of rental properties in Kota Damansara. So in this situation, there's nothing to do with what you call as a probability sampling. There's no probability involved, and there's no randomness because there's nothing, no words saying that it is a random sample. It just say that choose. If they say randomly choose, then it will be a random probability sampling. But in this case, it is just saying choosing. So this is a non-probability sampling. Okay. So in this situation, you can just say non-probability sampling. So this is non-probability sampling. And if you want to be more specific on this, so one of the appropriate sampling technique to be used in this case is convenient. Okay, so basically this is non-probability. So this one is probability. So kalau if they want is to classify as probability or non-probability. So the first one is simple random sampling. This is probability. So the second one also is a probability sampling. So probability sampling, to be specific, simple random sampling. The second one also probability sampling. To be more specific, it is a stratified random sampling. And for the last one, it is a non-probability sampling. And the more appropriate techniques will be the convenient sampling. Okay. Okay, the next one is similar to the past semester exam. They give you a scenario, okay, a situation, and then based on the situation, you have to answer several questions related to sampling techniques, data collection methods, variable, and so on. Okay. So the situation states that the management of a fitness center is interested in conducting a survey on the gym facilities provided at the center. Okay, from 250 registered members, a random sample of 50 members was selected to participate in the survey. The responses are summarized as below. So they give you the condition of gym facilities. So that is the situation, and then they give you condition very good, good, moderate, and poor. So you have the number of responses. So 18 people states that is very good, 25 state that is good, and then 5 states that is poor, moderate, and 2 state it is poor. Okay. So in this question, they ask you state the variable of interest for this study and identify its level of measurement. So what is the management interested of doing or of researching? Okay. So in this case, they want to know the condition. Okay, actually the response on the conditions of the gym facilities. So that is basically the variable. So this will be the variable. Okay, the response on condition of gym facilities. So your variable will be condition of gym facilities. Okay, and then what is the level of measurement? So in this case, when they ask the question, the condition of gym facilities, the respondent will give the answer, the response on the item, whether it is very good, good, moderate, or poor. So this is the responses. So these responses, you can see that it can be ordered, right? It is a categorical responses, very good, good, moderate, and poor. This is categorical because there's no numbers involved in the responses. And these responses can be ranked or can be ordered accordingly. So that means the level of measurement here will be ordinal. Okay, so the variable of interest will be condition. So this will be condition of gym facilities. Okay, and then the level of measurement will be ordinal. Okay, so that is the first one. Okay, the next one, it says you identify one possible probability sampling techniques to select the sample of 50 members. So what is the possible probability sampling techniques to select the sample? Okay, you can select the sample because this one, they just give you the list of the 250 registered members, right? Okay, you have the list of 250 registered members. So based on the management, so you have the registered member and you can come up with the list. So which means that is there a grouping or not? So in this case, there's no grouping involved. So that means stratified sampling, cluster sampling, and multi-stage sampling is not applicable. Okay, it's not applicable. So that means your answer gonna be either simple random sampling or systematic sampling. So which one to be used? So in this situation, you can answer both. You can use simple random sampling and you can also use systematic sampling. So that means for the second part here, identify one possible probability sampling techniques to be used. Your answer either SRS or systematic. If you answer for this question is stratified or cluster or multi-stage, then it is wrong. But if you answer SRS or systematic, it is correct. Okay, either one. You can give both. You can also give either one of these. Okay, so for 1 mark. And then explain in the sample selection process using the sampling technique chosen in 2. So this one for number 3, it depends on what is your answer in number 2. If you answered SRS, so that means, okay, I will just narrate the what you call the selection process. Okay, so if you cannot follow later on, you can just go back and go through my video for this one, and then you can narrate it once more, okay, together with me, and try to understand what is going on. Okay, if you are using simple random sampling, if your answer is simple random sampling, okay, what is the process? Step 1 is to list all the 250 members, okay, respectively. Okay, you have to list all the 250 members. Okay, it doesn't matter whether you are going to use a list from your records, or you just want to list the name according to the name of the alphabetical order according to their names, or you can also use their record numbers or members numbers. Okay, so you can do any kind of list as long as you cover all the 250 club members, right? Okay, that is the first step. The second step is number each of the members, okay, in the list. Okay, from 1 to 250. All right. And then the third step, using random number table, choose 50 members randomly. Okay, so using random number table, choose 50 members randomly. Okay, so that means once you have chosen the 50 members, let's say you have chosen based on the random number table, you have chosen number 20, number 14, number 16, number 23, 48, and so on until you get 15 members. And you locate this number, okay, locate the number from the random number table respective to the list that you have come up earlier. So that will be your respondent for your sample. Okay, that is if you are using systematic sampling. If you are using simple random sampling. If you are using systematic sampling, the first step is to list all the members from 1 to 250. The second step is to calculate the interval size. So the interval size K is given by N divided by small letter n. So in this case, you have 250 divided by 50. Okay, you get 5. Okay, so that is the second step. Calculate the interval size. Okay, and then the third one is to pick a random number between 1 through 5. Okay, pick a random number table, or random number. Okay, pick a random, just one number. Okay, just pick a random number 1 through 5. So let's say 3 is selected. Okay. Okay, let's say 3 is selected. Okay, so that means starting from the third person in the list, okay, you will select your respondent every 5 elements. So that means the first person selected will be the person in the third position, and then the person in the 8th position, you plus another 5, and then the person on the 13th position, 18th position, until you get 50 respondent. So that is if we are using the systematic sampling. So question number 3 depends on your answer in question number 2, right? And then the fourth one, give 2 guidelines to be considered in designing a good questionnaire. So this one you just can look up any the list of guidelines for designing a questionnaire. So you can just say, okay, no leading questions. Okay, that is one way. And then you have another, give a structure, simple questions. So that is another guideline, right? So clear and concise questions. So that will be another guideline. So you can give any guidelines related to designing a good questionnaire. So this one ada dalam you all punya textbook, okay? So you tengok dalam textbook ini, the last section in your textbook. And then finally, determine the most suitable data collection method and state one advantage. So again, you can just, because it says here the most suitable, so you just can think of any suitable data collection method. Since the number of population here is not so big, okay, you can just do a simple face-to-face interview. Okay, you can just using the face-to-face interview, or if you want to use the telephone interview also can, because you have the list of all the members, and then you can just texting the respondent through their record that you have from your registered. Okay, so that is in the form of the suitable data collection method. And then for the advantage, you can just give any advantage that is rational. Okay, so that's for the second part. Okay, for the question number 1. Okay, the next one that we're going to look at is question number 2. So this one is more in terms of the data representation in terms of graphical or table form, right? So in this situation, we're going to look at, it says here, a survey of 200 lecturers is done to know their preference towards a new attendance system. From the 200 lecturers, 80 are males, and then the result shows that 50% of the male lecturer preferred the new system and 45% preferred the old system. Majority of the female lecturers, 75%, preferred the new system, and only 5% of them do not any preference. Okay, don't have any preferences. Okay, so that is the situation. And then the question asks you to develop a contingency table. So not new or no preference. Or in this case, neutral. Okay, NEUTRL. Okay, neutral. So this will be the total. Okay, sorry about that. So that means in this case, this one is 80, 120, and this will be 200. So just now you have prefer the new, 50% prefer the new system, 45% prefer the old system. So new system is 50%, so that means 40 of them, and then 45% prefer the old system, and 5% prefer the has no preferences, right? So 0.5 times 80, so you get 40. 0.45 times 80, you get 36. So this one going to be 36, and this going to be 4. Okay, so let's see for the female. So the females, it says that majority of the female lecturers, 75%, prefer the new system, and only 5% of them do not have any preferences. Okay, so that means 75% out of 120. So 0.75 times 120, so you get this to be 90 of them. Okay, and then The being neutral, only 5%, so 0.05 times 120, so you get 6. Okay, so the rest will be prefer the old one. So 120 minus 96, so you get 24. Okay, so add these values together, so you get 40 plus 90, you get 130. So 36 and 24, you get 60. And then this one you get 10. Okay, so this will be your contingency table. So if you want to make it, create the borders, so you can create the borders. So let me just give this everything centered. So this will be your table. So just give it a color over here. So this one, let's say this one is, and then you have this value to be green, for example. This one you put it as, okay, just touch up over here. So this will be your contingency table. Okay, when you are asked to draw a contingency table, this is what you have to do. Okay. Okay, any questions so far? So this will be the contingency table, and of course you have to write the title over here. Okay, so this one is preferences, this one is gender. Okay, you have gender over here, and here will be the preferences, right? So let's look at another question. So that is for question number 2, and then question number 3 refer to chapter 3, that is descriptive measures. Okay, last time we have looked to the ungrouped data. So this is also part of, can be partial on top of the ungrouped data, because even though it's written in the form of a table, but it's actually a ungrouped data showing on a table base, okay, with a frequency. Okay, how you do this? Okay, the table below shows the number of telephone calls per day received by a courier company in the period of 65 days. So that means the number of days, if you calculate the total here, you're going to get this to be equal to 55. And then the number of calls is a discrete number, that is 30, 31, 32, 33, and 34. Okay, so when it says here 30 and the number of days 10, so that means there are 10 days where you receive 30 calls. Okay, so that means when you rewrite this information into a general or the raw data set, the ungrouped data set, you're going to have 30, 30, 30, 30, 30, 34, 10 times. And then you continue with, so this one you have 10 times. And then you continue with 31, 31 until 31. So here you have another 14 times. Ataupun kat sini, the times here will be in the form of number of days, right? So the question asks you right now, what is the median? So as usual, you need to find the location, median location. Remember, for median location is just simply equal to n plus 1 divided by 2. So this gives you 65 divided by 2. Sorry, plus 1. So 66 divided by 2. So you're going to get equal to 33. Okay, it's going to be 33. So you have to find the 33rd data. Where does it located? So for the first one, this one is from 1 to 10. And then this one is from 11 through 24. and then you have from 25 until 24 plus 13, you get 37, right? Okay, so that means 33 will be in this position, correct? So that means the median value will be the number of calls. So here, median is equal to 32. Okay, and then for the second one, you are asked to find the mode. So the mode here is simply looking at the highest number of days. So in this case, the highest number of days is 16, right? So that means the mode is this one. So mode is equal to 34. So that's it. So this is how you tackle the questions if they give you in the form of discrete value with a frequency. Okay, you cannot solve this using the group table, right? Because this one is a discrete value. The number of calls is in discrete value. It's not in the form of range from one value to another. Okay, so this will be the answer. The median is 32 calls, and then the mode will be 34 calls. Okay, so we move to the last one. So the last one, as usual, this one you need to find using the group data. Okay, using the group data formula. So the first one asks you to calculate the mean and the standard deviation. So as usual, as I mentioned earlier, in order to find the mean and the standard deviation, the first thing that you need to find is the summation value. Okay, you can do using a table form, or you can skip the table and find the summation using your calculator. Okay, even though you didn't use the function, you can also calculate it manually, but you have to find the summation of fx and summation of fx squared. So the first thing that you need to do here is firstly find the midpoint. So for each of the classes, you have to find the midpoint. So x here, okay, the midpoint will be first is 5, and then you have 7, and then you have 9, 11, and 13. Okay, so that is the value of x for the midpoint. So next, you can find the mean and the standard deviation. To find the mean and the standard deviation, the first thing that you need to do is to find the summation of fx and find the summation of fx squared. Okay, so that brings up the calculator. So let me bring up the calculator, and then we can do the calculation. Okay, let's do the calculation here. Okay, again, this one is already in the mode section, the statistical section. Okay, I'll be repeating this process. Okay, let me just switch off. Okay, you want the one, okay. Okay, now it's already in the normal mode. So the first thing that you need to do is to change into the statistical mode. Okay, if you are using other calculator, you have to look at other things. Okay, so I'll be showing you using this one. Okay, this one will be the same for the ES and the EX function. Okay, for the MS, it will be different. So I will do that later, right? So this one, choose the statistical function. So you have 3, and then choose the one variable, number 1. Okay, now it's already in the frequency. So if it doesn't appear in the frequency, make sure you click Shift Mode and then scroll down. Okay, under for stat here. So make sure that you turn on the frequency if it doesn't appear at the first place. Okay, so in this case 1. Okay, all right, so now you have to enter the data. So enter x first. So x is 5, 7, 9, 11, 13. So 5, 7, 9, 11, 13. Okay, and then next goes for the frequency. You enter the first frequency is 5, second frequency is 15, third frequency will be 25, then fourth will be 30, and then fifth will be 25. Okay, so once you have entered everything, you can just clear the screen. And then right now we want the summation. Okay, so shift number 1, choose number 3, that is sum. So you want the summation of fx, choose number 2, equal sign. So you get 1, 0, 1, 0. So this one gonna be 1, 0, 1, 0. And then do the same thing for the second one, that is for the summation of fx squared. So shift number 1 and then number 3 and then choose number 1. Okay, select number 1, equal sign 10740. So 10740. So the next thing to find is the mean. So mean here is equal to x bar equal to summation of fx divided by n. So this gives you 1010 divided by 100. So you get this to be 10.1 in 1000 grams. Okay, or you can just rewrite to be 1 kilogram. Okay, so if you want the 1000 gram, it will be 1010. Okay, right, so that is for the mean. And then for the standard deviation, I will write down here. Later I will, let me just put it down here. Okay, saya tulis di sini lah. Okay, saya tulis di sini lah. Okay. So S will be the square root of 1 over 99, and then summation of fx squared minus summation of fx squared divided by n. Okay, so maybe we want to, let's just do it in other, right? So let me just erase this one. So this is quite messy. Okay, okay, 10740 and 1010. Okay, so just now we want the answer for summation of x. Just click on shift number 1 and then choose number 4 for the variable, and then you want the x bar, okay, number 2. So you get this to be 10.1. Okay, so you get 10.1. Okay, next you're going to look at the standard deviation. So let me just use the Excel just now to just scroll ke bawah ni. Okay, draw using this one. Okay, you have S is equal to the square root of 1 over n minus 1, and then summation of fx square minus summation of fx square divided by n, close bracket. So substitute the value, you get the square root of 1 over 100 minus 1 multiply with 107 10740. Okay, 40 minus 1010 square divided by 100. Okay, calculate this one. You can get the answer from your calculator. Okay, shift number 1 and then choose number 4 for the variable, and then you want sx, okay, number 4. So this gives you the answer 2.333. You get, okay, 2.333. Okay, so that is for the standard deviation. So let me just rewrite here. So S is equal to 2.333. Okay. And then the second question asks you to construct a histogram to represent the weight. Okay, to represent the weight distribution of the papaya. Okay, the histogram. So starting with the lower boundary. Okay, so you have 4, 6, 8. Okay, you have 4, 6, 8, and then you have the frequency 5, 15, 25, 35, 30, and 25. So let me just roughly draw it here. Let's just draw it here. So you have the axis. So start with 4, and then 6, 8, 10, 12, and 14, right? And then the value goes from the highest is 30, right? So the highest is 30, so you can use 5, 10, 15, 20, 25, 30. Okay, and then please label your axis. Okay, label your axis. Okay, so this one is the frequency, and then this will be the grams. Okay, this is in grams. Okay, the first value is 5, so you get 5 over here. Okay, and then the second value will be 15, 25, 30, 25. So 15, and then 25, and finally you have 30, 25. Okay, so this will be your graph. Of course, you have to draw this on a graph paper. Okay, so draw correctly, not a curve like this. So you must have a straight line, okay, using a ruler. Okay, and then the next question asks you, using the histogram, estimate the model weight of the papayas and comment on the value obtained. So you have to come up with the mode. So to find the mode, so just locate the highest value over here. So in this case, the highest value will be between 10 to 11, 12. So this is the highest bar. So you draw a diagonal from one end to another, and this will give you the mode kat sini. So you have the mode. So the mode here will be x hat is equal to 11. Okay, how do you know that I get 11? The exact value will be 11. Okay, so how do you know the value to be 11? So how do you know the value to be 11? Because you know that both the ends of this highest bar have the same height. So that means you can just take the average of 10 and 12. Okay, if it's not on the same height, both of these, so you cannot take half of it. All right, so you have to estimate from the graph. So in this case, based on the estimate from the histogram, you know that the mode is equal to 11. Okay, so that means this one is 11 gram, right? So not 11 gram. Okay, this is 1.1 kilogram. So what is the comment? How to comment this value? Remember, whenever you want to comment values regarding mode, you must have the word most. Okay, so what does this mean? So you can say most of the papaya with 1.1 kilogram. Okay, so you can say most of the papayas with 1.1 kilogram, right? So that is how you comment on the values for mode. And then determine the shape of the weight distribution using Pearson coefficient of skewness. So right now you have the value of mode. So you can use skewness is equal to mean minus mode divided by standard deviation. So I will write it here. So it will be, so let me just write it here. So mean minus mode, so mean is 10.1. So 10.1 minus 11 divided by 2.33. Okay, so this gives you 10.1 minus 11 divided by 0.2.333. So this gives you negative 0.386. Okay, negative 0.386. Okay, so this is a negative value, so less than 0. So this means that it is left skewed. Okay, it will be left skewed. Okay, and then the last one asks you to make comparison. So just now we have farm A, and then now you have farm B. They give you the mean and the weight and the standard deviation for papaya in farm B. So you have to compare which one has more consistent weight. Is it farm A or farm B? So you find the CV for A. So this gives you S divided by X bar times 100. So for farm A, you have, just now you have 2.33. You have 2.333 divided by 10.1 times 100. So this gives you 2.333 divided by 10.1 times 100. So you get 23.1. Okay. And then for B, just release this. Okay, for B, CV B, so you have 250 gram for the standard deviation. So that means, okay, 250 gram divided by this one, okay, divided by 1250 times 100. So this will give you 250 divided 1250. So you get 0.2 or 20. Okay, you get 20, right? So from here, you can see that you want the answer to be more consistent. Which farm has a more consistent weight? So if you want to look for a more consistent weight, so you have to look for a lower CV value. So coefficient of variation that have a lower value is more consistent. So in this case, comparing farm B and farm A, the distribution of papaya weights in farm B is more consistent compared to farm A. Why? Because Farm B has a lower coefficient of variation value as compared to Farm A. Okay, so this is the answer for the last one. Okay, so this complete our solution for chapter 1 until chapter 3, or the assessment 1 for your for the previous test, okay, for the previous semester.